All right, let's now talk about types of data sets. So types of data sets. All right. So yeah, we'll do that too. Um, so first one is record data, like tables, data matrices, document data, term vectors, transaction data, shopping cart style, graph data, like networks, uh, molecules, order data, so temporal, dealing with time, sequential, I don't know if I spelled that right, sequential, spatial, genetic. So these are just examples of the types of data sets. And why? Why is this important? Why is this important? Different data types require different similarity measures. Similarity measures, like what we were talking about earlier, when we're using the Minkowski distance and these other distances, um, algorithms, algorithms, and pre-processing, right? So recognizing the data type ensures you pick the right tool. And that kind of goes back to the whole idea here, where we can do the math, but is it in the right angle? Is it at the right scope? Is it right for what we're looking for? Yeah, we can do the math, but is it in the right way for us to get insights, whether we're doing regression or classification? All right, the next one is data quality. Data quality. Okay, so data quality. So so this is when we get into noise and outliers, right? So so problems, noise, outliers, missing values. It's where pre-processing can really help us. Duplicates, just wrong data. Um, consequences, consequences. Poor models, right? E.g., for example, the lone risk model denying good candidates, lone risk model denying good candidates, denying good qualified candidates, right? Solutions. This is when data cleaning comes in pre-processing. Data cleaning, um, imputing and deduplication. So getting rid of duplicates, getting rid of wrong fake data, working on missing values. So, and why? Because garbage in, garbage out. So, like, even the most advanced algorithm can't fix poor quality input. So, ensuring quality is often, 80% of the work in real world projects. Pre-processing is a huge part of data mining. And so, data cleaning and deduplication is huge. All right, so let's get a new one going. All right, now, and I'll bring, all right, similarity and dissimilarity measures. The similarity measures, right? All right, so similarity is the closeness. So higher is equal to more alike. Dissimilarity, dissimilarity is difference, right? Um, lower is equal to more alike. So, and then we went over the common measures, right? Euclidean, Manhattan, Minkowski. Um, there's also the cosine similarity. So we went over those three measures. So Manhattan, Euclidean, and Minkowski. Okay. And why is this important? Why? Why is this important? The definition of closeness directly determines which objects group together or count as neighbors. The wrong choice misleads clustering, classification, and retrieval. All right? So that's why that is important. All right, so now we can go over data pre-processing. Aggregation is one. Combine attributes and objects or objects. Sampling. Use subsets of data representatives. All right. Discretization and binarization. Binarization. Okay. Uh, convert continuous. Convert continuous data like real numbers and uh, uh, yeah, just pretty much real numbers, turning them into categories or like a binary value. Categories, binary values. All right. Transformation, normalization, standardization. Right. Dimensionality reduction, which is a big one. Get rid of try to eliminate the curse of dimensionality using PCA and SVD, which we'll go over more. Feature selection, creation. Remove redundancy or construct meaningful new attributes. So again, this is a lot of pre-processing here because what do we want to do? We want to get 80% of our work is going to be pre-processing and cleaning to make sure that our models work effectively. Garbage in, garbage out. So we want good stuff in, good stuff out of our models. So that is the reason why we focus on this. This is huge. All right, so the key takeaways of this whiteboard here, and I'm just going to zoom out. So the key takeaways of this whiteboard is know your data, the attributes, your objects, your quality. Pick the right similarity distance measure for your problem. Pre-processing is not optional; it's essential. And high-dimensional data requires special strategies. So this is data fundamentals. And I'm going to stop here. So I'll see you in the next one.